I want you to imagine something, and I want you to imagine it precisely, because most people who talk about this subject refuse to be precise. And imprecision is how you smuggle nonsense past an audience. Imagine a young researcher, chemist, say, or a structural biologist who has spent 11 years of her life getting good enough at her trade to ask one genuinely new question about how proteins fold. 11 years. Organic chemistry, biochemistry, X-ray crystallography, the long apprenticeship of failure that turns a smart kid into a scientist. And now imagine that somewhere in a data center that smells like nothing and contains no DNA, no carbon, no water, a machine has just generated 10,000 candidate answers to a question she hasn't even finished phrasing yet. And 3 of them are right, and it doesn't know which 3, and it doesn't care because it has no idea what caring would even mean. That is not a hypothetical. That is AlphaFold, more or less. And a dozen systems descended from it, operating right now, this year, on problems that used to define a scientific career. So here's my question, and I want you to sit with how uncomfortable it is. What happens to science, not to scientists, to science, the actual enterprise of understanding the universe, when the thing doing the discovering can outrun the things doing the understanding? What happens when the machine gets to the answer faster than any human mind, including the machine's own engineers, can figure out what the answer means? I've been chewing on this question for a long time, in one form or another, since long before anyone called it artificial intelligence. I trained as a biochemist. I have a doctorate in it, and I spent the early years of my career at Columbia doing the slow, exacting, deeply human work of figuring out enzyme kinetics, one painstaking measurement at a time. And then I spent the rest of my life writing about robots who thought faster and more clearly than the humans around them, and the humans who had to decide what to do about that. I gave those robots 3 laws because I was 21 years old, and I wanted there to be a clean, logical scaffold underneath the chaos, something you could reason from instead of just feeling your way through. John Campbell and I argued about those laws across a desk at the astounding offices more times than I can count. He'd push, I'd push back. And eventually we'd built something that held together, not because it was simple, but because every contradiction had been hunted down and resolved. That is the method. Strip a thing down to what is actually true about it. Refuse to skip a single step, and then see what stands up. So let's do that here, because everybody, and I mean everybody, the journalists, the venture capitalists, half the scientists themselves, keep skipping the steps on this one. They jump straight to, the robots are smarter than us now, which is sloppy, or it's just a tool, nothing to worry about, which is worse, because it's sloppy and complacent at the same time. Neither one survives contact with the actual brick-by-brick truth. Brick one. What does it mean for a machine to learn science faster than we do? Be precise. It does not mean the machine understands more. Understanding, in the sense, I mean it, the sense any working scientist means, it is the ability to take a result and place it inside a structure of cause and consequence, to say not just this happens, but this happens because of that. And if that weren't true, this wouldn't happen either, and here's an experiment that would prove me wrong if I'm mistaken. That's what falsifiability is. That's the whole machine Karl Popper handed us, and it's the machine that turned alchemy into chemistry and astrology into astronomy. What the new systems are extraordinarily good at is pattern completion at scales no human cortex was ever built to handle. Give one of these systems the geometry of 100,000 known proteins, and it will infer the shape of 100,001 with an accuracy that would have made a structural biologist in 1995 weep with joy or despair. I'm honestly not sure which. But ask it why the shape is, what aspect of the underlying physics of hydrogen bonding and hydrophobic collapse necessitates that particular fold and forbids the others, and increasingly the honest answer, from the people who build these systems is we don't fully know either. The machine found the pattern. The mechanism is still ours to dig out by hand the old way after the fact. Now, here is where it gets strange, because you'd think that's a comfortable division of labor, wouldn't you? Machine finds the pattern, humans explain the pattern, everybody keeps their job, science marches on arm in arm with its new fast little friend. Except the patterns are arriving faster than the explaining can possibly go. There are more candidate protein structures generated in a year now than there were total solved structures in the entire history of crystallography before AlphaFold existed. You cannot explain that volume of result by hand. You cannot even read it by hand. So what happens, and what is already happening in labs I have corresponded with people about, is that scientists begin reasonably, defensibly, and this should worry you a little, to use the predictions without the explanations. They take the output as a kind of oracle, not because they've decided to abandon the search for mechanism, but because there are only so many hours in a life and only so many mechanisms one laboratory can chase down, and the queue of unexplained correct answers just keeps growing behind them, like water behind a dam that was never built to hold this much. I want to give you a thought experiment because I think it makes the danger tactile instead of abstract. Imagine you've never seen a chessboard, never been told the rules, and someone hands you 10 million completed chess games, just the move sequences, white's moves and black's moves, nothing else, and tells you your job is to predict, given any partial game, what move comes next. Given enough games and enough computational muscle, you could become extraordinarily good at this. You'd learn that certain patterns of pawns tend to precede certain explosive tactical sequences. You'd learn openings without anyone telling you they were openings. You would, in a very real and measurable sense, become a superb chess predictor, but you would not know that a bishop moves diagonally. You would not know what check means, or why a king matters more than a queen. You'd be operating one full level below the actual logical structure of the game, riding its statistical shadow with tremendous skill. That is, as best as anyone can tell, roughly the position of a large pattern-completing system set loose on the genome, or on material science, or on the dynamics of protein interactions inside a living cell. It is riding the statistical shadow of the chess game of physics and chemistry, and it is getting frighteningly good at predicting the next move without anyone, machine or human, being entirely sure it has discovered. In any sense, we'd recognize that a bishop moves diagonally. That ought to unsettle you, and if it doesn't, you haven't thought about it hard enough yet. So let me push further. Because the chess analogy has a comforting limit built into it, chess has finitely many legal positions, and somewhere underneath the statistics, there really are explicit rules waiting to be reverse engineered, rules a sufficiently clever human could eventually write down completely. Nature might not be so kind. We don't actually know that the universe bottoms out in rules simple enough for a human mind evolved on the savannah to track antelope and avoid leopards to ever fully hold in its head. We assume it does, because every time we've dug deep enough, we've found an elegant equation waiting at the bottom, Maxwell's 4 equations holding all of electromagnetism. Schrödinger's equation holding the quantum world, gravity reduced by Einstein to the curvature of a 4-dimensional sheet. That run of luck is the entire unspoken faith underneath the scientific enterprise, that the universe is, in some deep sense, explicable to creatures like us. Nobody has ever proven that. It has simply, so far, kept being true. And now, we've built machines that can find correct answers via a route that doesn't require that faith to hold. They don't need the universe to be explicable to mammalian brains, because they're not mammalian brains. They're statistical engines chewing through dimensionality we can't visualize and wouldn't survive trying to if it turns out that some significant fraction of nature's real machinery is irreducibly complex in that way, comprehensible to a sufficiently large pattern matcher, but not compressible into anything a human can hold in, working memory and reason from, then we are not looking at a temporary lag where the explainers just need to catch up to the discoverers. We're looking at a permanent fork in the road where one branch of knowledge keeps producing true, useful, verified results that no human being will ever, in the old sense, understand. I have to tell you about a wrong turn I made, because I promised myself decades ago that I'd always tell you about the wrong turns, not just the times I got it right. That's the only way an argument earns any trust. In my foundation stories, I built psychohistory, the science of predicting the mass behavior of populations of trillions across galactic time, and the engine that made it work in the fiction was the assumption that even though no single human mind could track all the variables themselves were of a kind humans understood: economics, sociology, the friction of bureaucracies, the inertia of empires. Harry Seldon's mathematics outran any individual human's ability to compute it, but it never outran human comprehension of the kind of thing being computed. I thought that distinction, outrunning computation while staying inside comprehension, was the safe, stable arrangement, the one science fiction could rely on, robots and prediction engines that were faster at arithmetic but were still doing recognizably human arithmetic underneath. I no longer think that distinction is guaranteed to hold in the world we're actually building. The new systems aren't just out-computing us on problems we already understand the shape of. In some domains, they may be operating on a different shape of problem altogether, one that doesn't reduce cleanly to the categories human science built up over 4 centuries from Galileo onward. I wrote psychohistory as if the bottleneck were always going to be computational horsepower. I am no longer sure that was the right bottleneck to worry about. The real bottleneck might be conceptual, not computational, and conceptual bottlenecks don't dissolve just because you add more processors. Let's take this out of the realm of the hypothetical, because I promised you real science, not parable, and the real science is, if anything, stranger than what I've just described. Go all the way up off the Earth to a planet called K2-18b, 8.5 times the mass of our own, circling a small red dwarf star 120 light years off in the constellation Leo. In 2023, and again in 2025, a team led by Niku Madhusudan at Cambridge ran the James Webb Space Telescope's infrared eye across that planet's atmosphere as it transited its star, and they reported a tentative signal, not a triumphant announcement, a tentative one. And I want you to notice that word tentative, because the honest scientists always use it and the dishonest popularizers always drop it, of dimethyl sulfide, a gas that on Earth is produced almost exclusively by marine phytoplankton. A James Webb Space Telescope team detected molecules in K2-18b's atmosphere they claimed could be a biosignature, dimethyl sulfide, a gas produced on Earth exclusively by marine life. Controversy followed. And what a controversy. Independent groups went back into the same public data with different statistical retrieval frameworks, and the picture splintered. One careful reanalysis found that the vast majority of retrievals using their preferred method for handling the instrument's mid-infrared data did not support the detection at all, and concluded that what looked like a signal might simply be unresolved noise in the instrument rather than anything coming from the planet. Other teams, running yet other statistical pipelines on the very same photons, kept finding methane and carbon dioxide rock solid, but lost the dimethyl sulfide entirely, or found it was statistically indistinguishable from an entirely different, utterly lifeless molecule. As of right now, the honest state of the science is unresolved, contested, and very much alive, as an open question, not settled in either direction. And any version of this story you hear that announces a confirmed discovery of alien life on that planet is, I promise you, getting ahead of the data in a way that should make you suspicious rather than excited. Now, why am I telling you this particular story with this much unresolved mess left visibly in it? Because it's the cleanest real-world example I know of the very problem we started with, except run on human beings instead of machines, which makes it easier to see. And that's exactly the point, because the machine version is coming next, and it's going to be worse. Even with human scientists working with full understanding of the chemistry and the statistics, a single ambiguous data set produced 5 or 6 mutually incompatible interpretations depending on which retrieval algorithm and which binning of the wavelength data you trusted. The information was insufficient to force a unique conclusion, and intelligent, well-trained people who fully understood every assumption in their own models still disagreed, sometimes sharply. Now, imagine that instead of 5 human teams with explicable, arguable, publishable methods, the analysis had been handed entirely to a machine learning system trained to find biosignature-like patterns across thousands of synthetic spectra. A system that might output a number, a confidence score, a yes, 83%, with an internal weighting of 10 million parameters that no living person, including the people who built it, could walk you through line by line. You would have a verdict. You would not have an argument. And an argument, open, falsifiable, capable of being torn apart and rebuilt, is not a decorative feature of science. It is the load-bearing wall. Take it away, and what you have left looks like science, costs like science, sometimes is even right as often as science, but it is not the same kind of object, and I do not think we have fully reckoned with how much we'd be giving up. Let me hand you a second thought experiment, because the K218b business is about evidence, and I want to show you the same fracture line in the business of theory. Picture a sealed black box the size of a refrigerator that you cannot open. You feed it the positions and velocities of every planet in the solar system, going back as far as your records run, and you ask it to predict where Mars will be 1,000 years from now. It tells you, and it is right every single time, to 10 decimal places forever. Have you done astronomy? I would say no. Kepler did astronomy when he looked at Tycho Brahe's painstaking decades of naked eye measurements and noticed, against his own preference for circles, that the orbits had to be ellipses, and in noticing that, he handed Newton the raw material to derive gravitation itself, the inverse square law. A piece of reasoning so portable, it later predicted the existence of Neptune from nothing but the unexplained wobble in Uranus's path, and predicted the bending of starlight around the sun that Einstein's general relativity required, and that Eddington went out to a solar eclipse in 1919 to actually measure with photographic plates, confirming it. That entire 4th-century chain, Brahe's data, Kepler's ellipses, Newton's law, the discovery of Neptune, Einstein's correction. Eddington's eclipse is a chain of comprehension, each link forged by a human mind that could be questioned, that could be wrong in a traceable way, that could be improved by another human mind picking up the argument. The black box that just spits out Mars's future position to 10 decimal places gives you none of that chain. It gives you the answer without the argument, the destination without the road. And if the box is ever wrong, if some entirely new physics shows up at the edge of its training data, a fifth force, a previously unseen body, you will have no idea why it's wrong or how to fix it, because you never knew why it was right in the first place. That is not a fantasy box. It is, in spirit, what is already starting to happen inside laboratories doing material science and drug discovery, and even some corners of fundamental physics right now, this year. Machine learning systems are proposing new candidate materials, battery chemistries, room temperature superconductor candidates, novel catalysts at a pace that has gone from a curiosity to a genuine flood, And a meaningful fraction of those proposals, when actually synthesized in a real laboratory by real chemists with real Bunsen burners and real mass spectrometers, turn out to work. They have the right properties, the conductivity is there, the catalytic activity is there. And in plenty of those cases, nobody can yet give you the clean structural reason why the elegant story about orbital hybridization or lattice strain that a materials science textbook from 1985 would have demanded before it. Let the result anywhere near a respectable journal. The result arrived through the back door, through the same kind of statistical pattern matching that's hunting for life on K218b, and the front door, the explanation, the mechanism, the part that lets a human being say, ah, now I see why is being filled in afterward. Sometimes successfully, sometimes only partially, sometimes not at all, with the unexplained result, simply banked and used because it works. And there isn't time to fully understand every banked result before the next 10,000 arrive. I want to be fair here, because I have zero patience for hand-waving, but I also have zero patience for cheap doom. There's an argument, and it's not a foolish one, that this is exactly how science has always worked, and that I am being a romantic about a golden age that was never quite as golden as I'm painting it. Plenty of real chemistry happened through trial and observation long before anyone had a theory to explain it. Willow bark relieved pain for centuries before salicylic acid and the prostaglandin pathway were ever identified, and nobody seriously argues that the Egyptians and the Greeks weren't doing real medicine when they used it, just incomplete medicine. Mechanism, on this view, isn't the price of admission to knowledge. It's a bonus round you collect later, sometimes much later, sometimes never, and the empirical fact still stood on its own all along. There's real force in that argument, and I want to give it room, because I'm not interested in winning an argument by pretending the other side has nothing. But, and here's the brick, I think that argument is missing. There's a difference between a result with no mechanism yet discovered and a result with no mechanism discoverable by any human mind in any amount of time, because the pattern that generated it lives in a representational space too high-dimensional for a human nervous system to ever hold. Willow bark's mechanism was always there, waiting, expressible eventually in concepts a human chemist could learn and hand to a student. We have no guarantee, none, not one, and this is the part that genuinely keeps me up some nights, not in a comfortable theoretical way, but in the way a real open problem should keep a scientist up, that every true pattern these systems are finding has that property. Some of them might, some of them, I suspect, fundamentally do not, and translating them into anything a human brain can use as a foothold for further reasoning may be not merely difficult, but in the strict mathematical sense, impossible. The way you cannot losslessly compress certain information past a hard floor, no matter how clever your scheme. If that's true, even for a meaningful slice of what these systems are finding, then we are not facing a temporary gap to be patiently closed by smarter explainers and better visualization tools. We are facing the emergence, inside science itself, of a permanent category of true things that work, that we can verify experimentally over and over, and that no human being will ever, in the full and satisfying sense Kepler and Newton gave us, understand. Now here is where it gets strange in a different direction, and this is the part I find almost unbearably interesting rather than simply frightening. So bear with me. Because if that's right, if there really is a layer of nature's actual machinery that is comprehensible only to a sufficiently vast statistical engine and not to a human cortex, then we have stumbled onto something that cuts to the very oldest question I ever wrote about, the question I chased across 400 robot stories and the entire Foundation series without ever quite catching it. What is a mind, and is understanding the universe something only a mind shaped like ours can do, or is it something any sufficiently structured information processing system can do, regardless of what it's built from. I used to think, when I wrote Susan Calvin solving robot puzzles through pure deductive logic, that intelligence and human-style comprehension were essentially the same thing wearing different hats, that anything smart enough to find the right answer was, almost by definition, smart enough to explain it, because finding and explaining seemed to me like two views of one underlying capacity. I think now that was too tidy. I think finding and explaining may be two genuinely different operations that happen to travel together in biological brains for reasons rooted in how natural selection actually built us a slow, narrow bandwidth, storytelling, cost-seeking organ optimized to track which other primate stole the fruit, repurposed by sheer evolutionary luck to occasionally do astrophysics, and that there's no law of the universe requiring those two operations to travel together in every kind of mind that could exist. We may be building the first kind of system in history that can do one without the other at scale. Find true things reliably, reproducibly, without ever explaining them, because the engine that found them isn't shaped anything like the engine that wants explanations and would recognize one if it saw it. And that connects, if you let it, to the absolute largest question there is, the one I treated as dead serious science in my fiction and not as poetry, because I think it deserves to be treated as dead serious science here too. What is information, fundamentally, and what is its relationship to the thing we call understanding? And is understanding even a property of the universe, or just a peculiar comfort that one particular species of self-replicating carbon-based chemistry insists on demanding before it will believe something is true? Erwin Schrödinger asked something close to this in 1944 in that little book, What is Life?, that supposedly nudged Watson and Crick toward DNA. He asked how a living organism manages to extract order from a universe that is, by the second law of thermodynamics, sliding remorselessly toward disorder, and his answer involved information, code, structure, resisting entropy through pattern. I think the question in front of us now is the next chapter of that same inquiry, not a separate one, is comprehension itself, a kind of order that only certain architectures of matter can extract from the chaos of raw data, the way only certain architectures of matter cells, DNA, metabolism, can extract biological order from the chaos of raw chemistry? If so, then human science, the whole glorious 4th-century project from Galileo's telescope to Webb's infrared mirrors, may turn out to have been one particular species' way of imposing order on a universe that doesn't actually owe us comprehensibility, and these new machines may be the first instrument we've ever built that touches the universe's actual machinery without bothering to translate it into the particular dialect of order that our species happens to find satisfying. I don't know the answer to that. I want to be completely straight with you about that, because intellectual honesty was the only currency Campbell would actually accept from any writer at that desk, and it's the only currency I trust now. I don't know whether the gap between machine discovery and human comprehension is a temporary scaffolding problem will dissolve in 20 years with better interpretability tools and smarter visualization and patient cross-disciplinary work, the kind of optimistic bet plenty of serious, careful people in the field are making right now, and reasonably so, or whether it's the first visible edge of something genuinely new in the history of inquiry, a permanent zone of true, useful, experimentally verified knowledge that simply sits forever outside the reach of any explanation a human being could hold in their head and pass to another human being, the way Kepler passed his ellipses to Newton. That uncertainty is not a flaw in my argument that I'm apologizing for. It's the actual honest shape of the problem. And I'd rather hand you an honest, unsolved problem than a tidy, false comfort. Because the tidy, false comfort is exactly what gets people killed later, intellectually, if not literally, ask anyone who believed continental drift was nonsense, right up until the seafloor spreading data made the position untenable, or anyone who was certain Venus's surface was a lush jungle, right up until the Soviet Venera probes radioed back data from 460 degrees of furnace heat. So let me leave you with this, because a chess match doesn't end with a summary, it ends with a move that changes how every previous move has to be read. We built science as a conversation between observation and explanation. 4 centuries of it, each generation handing the next one not just results but reasons, a chain of comprehension stretching back to Galileo's tilted telescope. And we built that conversation because comprehension was the only tool we had for separating a lucky guess from a real law of nature. We are now, this year, watching machines join that conversation that can supply the observation vast amounts of it, more than any human team could check in 100 lifetimes, while the explanation half lags behind, sometimes catches up, and sometimes, I suspect, never will. Not because we haven't tried hard enough, but because some of what they're finding may not be made of the kind of thing a human mind can turn into a story. We do not yet know whether that gap closes or widens. We do not yet know whether we are the last generation of scientists who will fully understand the science being done in their own name, watching from the shore as the actual frontier moves somewhere. Our kind of mind was never built to follow. I have spent a long life insisting that the universe is, in the end, something we can reason our way into, brick by brick, and I am telling you tonight, as honestly as I know how, that for the first time in that long life I am no longer certain that's true, and I would rather leave this stage having handed you a real fracture in the foundation than a comfortable lie poured smooth over the top of it, because the lie feels better walking out of here, and the fracture is the only one of the two that's actually yours to do something about.